Welcome to This Explainer. Today, we're diving straight into the really fascinating world of database relationships. And to make this incredibly concrete, we're going to use a highly relatable university environment to see exactly how scattered, everyday data gets transformed into a highly structured, manageable reality. We interact with databases literally every single day, yet the architecture holding it all together is completely invisible to us. Well, today, we're making the invisible visible.
Seriously, think about this for a second. How do databases actually know who you are and what class you're taking? When you log into your student portal, you see a nice, clean schedule. But behind the scenes, there are these invisible strings connecting your daily interactions. Without these defined relationships, a university database is really nothing more than a chaotic, disconnected list of isolated names, room numbers, and classes. It's the relationships that actually give the data its meaning.
Here's our quick roadmap for today. 1. What is a relationship? 2. Unary, the solo connection. 3. Binary, the dynamic duo. 4. Ternary, the three-way link. And 5. Quaternary, the complex web. Let's get right into it.
Section 1. What is a relationship?
Okay, so by definition, a relationship in a database is an association between two or more distinct entities. Simply put, a relationship tells us exactly how data points are connected. If you have an entity called student and another entity called unit, the relationship is the bridge between them, like a student registering for a specific unit. It's the exact mechanism that binds independent facts into a cohesive story.
To make this instantly click, I absolutely love using this brilliantly simple noun-verb analogy. Just think of your database as a sentence. The entities, the distinct objects we want to record data about, are the nouns. This is your student, your lecturer, your unit. The relationships, on the other hand, are the verbs that dictate the action: registers, teaches, supervises. A student, that's our noun, registers, our verb, for a unit, another noun. It's hands down the most direct way to grasp how we map real-world interactions into abstract data concepts. Now, we need to make a really quick distinction between an individual relationship and a relationship set. A single relationship is just one specific occurrence. For instance, John registers for database systems. But databases don't just look at individuals, right? They look at the collective. A relationship set is the collection of all similar relationships of the exact same type. So the relationship set here is all students registering for all classes. It's how databases group similar connections together to form a robust searchable structure.
Moving on to Section 2, Unary, the solo connection.
We're starting with the number 1 here because we're looking at relationships involving just a single participating entity type.
So a unary relationship, you'll also hear it called a recursive relationship, occurs when one entity type is related to itself. I know, that kind of sounds like a bit of an oxymoron. How can something relate to itself? It's not a database talking to itself in the mirror. In database logic, it simply means that a single entity table contains connections between the records inside that very same table. Let's look at some everyday university examples to clear that up. Imagine a university hierarchy. A senior lecturer supervises a junior lecturer. Notice that the word lecturer appears twice. Even though there are two different people involved, they both belong to just one single entity type in the database, the lecturer entity. The exact same thing goes for a fourth-year student mentoring a first-year student, or one department collaborating with another. It's literally one table looping back on itself to show an internal hierarchy or connection.
All right, Section 3, binary, the dynamic duo. This is the most common connection you're going to see in database design. And here's the number 2, which signals our transition to exactly two different participating entity types coming together. A binary relationship involves exactly two different entity types. This is your classic dynamic duo of databases. It's the standard, most fundamental way we connect distinct sets of data in our daily lives. Think of a student registering for a unit, a lecturer teaching a course, or a department offering a degree program. Entity A interacts with entity B. As you'll see here, this perfectly illustrates a binary relationship set in action. Over on the left, we have the instructor entity set, Einstein, Katz, Crick. On the right, we have the student entity set, Shankar, Brown, Peltier. The lines drawn between them represent the advisor relationship. It shows exactly how individual instructor entities link directly to their advised student entities. Two distinct tables bound together by a totally clear, undeniable relationship. Section 4, ternary, the three-way link. Let's see what happens when two entities just aren't enough to capture a real-world business rule. Enter the number 3,
A ternary relationship means three distinct entities are now participating simultaneously to make a single meaningful connection.
Now, you might be wondering, hey, why isn't a binary relationship always enough? Well, consider these scenarios. If our database only says lecturer teaches unit, we're missing a massive piece of context. To which class? If we change it to lecturer teaches class, well, now we've lost the information about what unit they're actually teaching. And if we say unit belongs to class, we don't know who the instructor is. Removing any one of these three entities entirely changes the context, proving that we absolutely need a ternary relationship to capture the whole truth of the event.
This setup right here brilliantly illustrates the solution. Take a look at this entity relationship diagram for a project guide setup. We've got an instructor, a student, and a project. The diamond in the middle connects all three simultaneously. It dictates that a specific instructor guides a specific student on a specific project. You literally cannot just split this into binary pairs. If you did, you might know that an instructor works with a student and an instructor works on a project, but you'd completely lose the specific data of who did what together.
Section 5, Quaternary, the complex web. Let's see how this builds into an even more complex web of data at the very top of our ladder.
4. The quaternary relationship. 4 different entity types, all bound together in one single simultaneous relationship.
A quaternary relationship involves 4 distinct entity types participating simultaneously in a single event. Now, to be totally clear, this level of complexity is pretty rare in basic database design, but it becomes absolutely necessary when mapping highly detailed and credibly specific real-world events where leaving out a single variable would ruin the integrity of the data. Let's walk through an example piece by piece. Imagine a student named John. John registers for a unit. Let's call it database systems. That unit is taught by a specific lecturer, Dr. Mwangi, and this all happens during a specific semester, let's say semester 2. To accurately record this single event without losing any vital administrative context, all 4 distinct entities, student, unit, lecturer, and semester, must be linked together at the exact same time. It's a perfect 4-way intersection of data.
So, the absolute crucial takeaway is summarized right here in this cheat sheet. I'd highly recommend pausing this explainer for a second and taking a quick screenshot. It perfectly maps our 4 relationship categories to their degrees and the university examples, from the solo recursive loop of a unary relationship all the way down to the intricate 4-part harmony of the quaternary relationship. Understanding this table means you genuinely understand the fundamental architecture of how data mimics the real world.
We're going to wrap up with this thought. Every time you register for a class, buy something online, or even just stream a song, you are participating in these exact types of database structures. As databases continually map our reality, what unseen complex relationships are currently defining your digital footprint? Start looking at your everyday digital interactions, not just as isolated clicks, but as an incredible, structured web of data relationships. Thank you so much for joining me on this explainer, and keep questioning the data around you.